you can unmute yourself, Mr. Usman Ismail. Okay. You need to unmute yourself. You have the floor. Maybe, yeah, then let's move to the next person while we wait for him to respond later. Dr. Bashir Sodipo. Dr. Bashir. I can't hear the response. Maybe they're not. Is there any issue? Oh, sorry. I think it's from my side. Yeah. I go back now. Let's start from Mr. Usman. Sorry. Yeah, the setting doesn't allow you to unmute. Yeah. Mr. Usman, you have the floor.
Good Prophet, not that one.
Yeah. Please. Yeah. Mr. Usman, you are recognized.
Okay, good.
Now, kindly unmute yourself.
Yeah, I'm now on mute.
Yeah, okay.
So actually, I've just want to talk about when you upload the data. I've noticed that there is a section apart from the instances. Then there is a weight section, like what's the weight of maybe yes or weight of no. So when is it important to kind of touch it, or you don't always touch it?
Come again. Sorry, I can't get your question. You said when I uploaded in the WEKA, is it in WEKA?
In the WEKA, yeah, there was. It's WEKA. There was a target, and then there are instances, and then there is the weight of the instances, which was the same for this data set. We didn't touch it. So I was asking, is it always necessary to leave it as it is, or do you need to tweak the weight? That's what I wanted to kind of confirm.
Okay. Let me open it. I hope I get what you mean by the weight.
Yeah, when you weight, there is number, level,
okay. By the weight. Yeah. Okay. Yeah. This is always okay. Yeah, this is not normal. It's just telling us this is the number of distribution of your attributes. It's distributed into 14,274 years, and then no. So they are basically, each one is having a unique weight. That is why the weight is also set up to the number, as the case may be. Yeah, we don't touch it at this particular level, actually. So, and like I said, it's better to first of all run the experiment. Like you see now, even without doing anything on the data set, we got 100%. It's very simple, our simple classifier like any nearest neighbor. So it is when it failed, we are not getting something interesting we want, then we now go back, maybe something is wrong with this data. What can we do about this data? Can we do feature selection? Of course, in this case now, we can still go ahead and do feature selection because presently we are having 13 features. It means for anybody to be able to check himself or herself for hypertension using this model, they need to have to answer 13 questions. So they need to do their cholesterol level and some other questions or maybe tests. So can we reduce it? So we can try to do feature selection on this and then say, okay, how far can we go and which of the features will even be able to give us the same accurate result or near to that level of accuracy by reducing the number of features, because reducing the number of features make it easy for people to use the application. When people hear that you need 13 answers to use my model, people start thinking, oh, I don't have time. Can we reduce it like 3 most important questions? And then people can easily diagnose themselves that they might be having hypertension or otherwise. So thank you very much. So now, you still raise up your hand, Mr. Usman. Is that all about your question?
Yeah, it's all. Thank you very much.
Okay, thank you very much. So, Dr. Bashir, you have the way.
No. Assalamu alaikum.
Alaikum salam wa rahmatullahi wa barakatuh.
Now, Jazakallah khairan for the effort. Please, my question is, after the whole thing, if the model doing maybe publication or report writing, which model exactly one is going to copy or report?
Okay, thank you very much. Yeah. So I think we answered something similar before, but then we also tell us again. Regarding the modeling is what you have done here. See, this, whichever one you have used. So what is the model? It's made up of the algorithm you have used. You have to tell them what is the algorithm and how does it work. And also, very important, how did you partition your data? Because if you don't tell us after you have partitioned your data, there's no way someone else will repeat what you have done. So tell us, this is what we call experimental setup. Remember, I gave us a sample research report format under experimental setup. I mentioned those things that are very, very important. Those are the model, actually. Yeah. And it's not buried in the equation or whatever. No, KNN is a very popular algorithm. People know it's very popular. Just say we use K nearest neighbor has been deployed in this work. Of course, it's good to have a description of the algorithm, a summary description, mathematical description. If you can link it with your own work you are doing, this is excellent. You see, that is mathematically let people know, okay, this variable represents this one represents this. In this problem, we have like two classes, yes or no. Yes means there is hypertension, no means there's no hypertension. Those basic description. And then you go into the experimental setup and make it very clear. And what are they? The algorithm you have used. We use K nearest neighbor. If we are talking of K nearest neighbor here, yeah. So then you have to go in there in the K nearest neighbor. What is the hyperparameter values that you have used? And remember here we mentioned 8. This is let me show us to make the explanation clearer, hopefully. Yeah. Yeah, because I need to go back to it, 70%. Okay, yeah. Build the model. So this is the model we built. So you have to tell us what is the hyperparameter of the model that you have used. And in a K nearest neighbor are majorly 2 hyperparameters. You see, when you click this is the hyperparameter 1. And I think we have described what is the difference between parameter and hyperparameter. This is a parameter. This is hyperparameter. Hyperparameter, they are the parameters that affect the algorithm itself. It affects the performance. So the value is 1. With KNN equal to 1, we're going to record it there under your experimental description in your report. All this batch size, number of decimal places, they are just parameter that is sent to the back end, from front end to the back end. I want the output to be 2 decimal places and the likes. The second hyperparameter is the distance measure. You have to, compulsory, you have to tell us. You have to make it very clear. Okay, this is the hyperparameter. This is the hyperparameter value for the distance measure. In this case, we have used Euclidean distance. And then we say sometimes it will be good to also show that, okay, we search for some of the best, but this is the one that gave us the best. Somebody we might support with the plot or whatever. It depends on how clear you want it to be. Yeah. But most importantly, what we have to mention is the hyperparameter of the algorithm you have used, the hyperparameter values you have used for those algorithms, and the partitioning method you have used in your development. How did you partition the data? This is the model you are going to report. And that is enough. So, because anyone that picked that did that small area of your work should be able to go to the platform you have used and repeat your experiment. If anything is missing that will make that thing impossible to do, then your model description is not complete. So these are the most important information that we have to provide, as the case may be. I hope that answer your question, clarified.
Yes, Jazakallah khairan. It does.
Yeah, barakallahu fi, Doctor. Now, Mr. Abdul Salam.
During the session,
Okay.
you mentioned the name of an algorithm.
Okay.
That doesn't affect the hyperparameter.
That does not need hyperparameter?
Yes, sir. Yes, sir.
Okay, okay.
So I wanted for the name of the algorithm.
Okay, okay, you can see, I hope you can still see my screen here. We have this, once you open WEKA, by default, we have this 0R algorithm. It's usually sent to default. This was the first one. Once you open your WEKA, you feed as the default. It's very simple one. So it does sometimes, weirdly, it works in some data set that other algorithm doesn't work. It depends on the nature of the data. That's why we always say let the data speak. However, the second one, this one doesn't have, once you select, how do you know if there's hyperparameter or no hyperparameter? Hey, let's go to classifier. When you select a classifier, like this IBK now, you can see all these things listing. You can see here, this is IBK. You can see K is got to 1. K, it means the value of K nearest neighbor is set to 1. Then the next one is the search algorithm. That is the Euclidean, the distance measure. This is Euclidean distance. It could be Chebyshev, it could be Manhattan and the likes. So what have been listed here, they are the hyperparameters, the parameters that are actually associated with that algorithm. It means with them, you can play with them to get better results. If you don't do it well, you might not be able to achieve good results. So this is the hyperparameter for this. But sometimes when you open some algorithm, like Bayes, naive Bayes, you can see here there's nothing in front of naive Bayes. It is empty. See, it means that naive Bayes has no hyperparameter. And we discussed it in some of our very early part of our engagement in this forum. So you can search some of our video on naive Bayes classifier. We discussed it then. You see, by the way it was on previous principle of probability. Once we compute the probability, then we just use the probability function to do the prediction finally. So there's no any hyperparameter we are going to change. So that is why we said, okay, there's no hyperparameter to be changed for this kind of classification model. It means the disadvantage is that once you use it and it doesn't work for that data, you don't need to, there's no need to waste your time on hyperparameter tuning and the likes. No, because it doesn't have. See? But for others, like the IBK decision tree, support vector machine has so many parameters that you might actually play with. So those are the ones we mentioned. Once you load it here, you see if nothing is listed together in front of it, it means it doesn't have hyperparameter. If I click it, it brings out something. These are just batch number of decimal places. These are basic settings. They are not connected to that algorithm itself. Yeah. So those ones that are listed in front, like for the K nearest neighbor, we used earlier, you can see here 2K and this search measure. These two, they are the upper parameter, and these are number 1 is here, the second one is here. Others are just normal parameters. That's when we differentiate between parameters and hyperparameters. Thank you very much. So, and it was last Mr. Hakim. Hakim.
Assalamualaikum, sir.
Walaikum salam wa barakatuh. How are you?
Jazakumullah khair. Alhamdulillah.
Barakallahu feek.
I have 2 questions.
Okay.
And maybe one comment.
Okay.
The first question is about this smooth when we want to do data balancing.
Okay.
I want to ask that I have a data. Let me explain the way I did it, and I just want to ask your comment on it. I have a data, and then I divided into training and testing set. So for the training set, I use smooth to balance the different classes. It's a 4-class problem. I used the smooth method. I didn't apply the smooth on the testing, which I kept separate. Is that the appropriate way to do, or balance the whole data and then divide into training and testing sets? That's my first question.
Okay, thank you. I think you have to be very just to your data. So if you are training a model with data balance with smooth, then you have to also test it with data balance with smooth, except if you are sure that the data that is coming in this time around Hello. Yeah.
Hello, sir. I can hear you, sir.
Okay. Yeah. Thank you very much. Yeah. If you have trained, you are training and testing. Now, where the most important, to be factual, is the most important is the training set. You get the point. Once you have the training set, balance out, because it means a model is going to be generated that will have the capability to identify any sample from either A or B. This is the idea, actually. So the training set is the most important. You balance it. Yeah. However, once you have balanced it, it's also good to have, for your testing set, it's good to have representative values, a number of samples from each class in a distributed way to be able to ensure that your final assessment is going to be correct also. Because, for example, now you have only 2 samples from the testing set, from class A, from one class in the testing, and many samples from the other class during the testing. But the training set were balanced. Then when you are going to see this class, there's no way you will know if it's doing fine or not. This is the problem with it. But it's not compulsory. Because in testing, let's say after I train my model, if I'm able to check it using another one that is balanced, it's better. And I'm sure it's okay. If I have a new sample now coming in, that sample might even be only one sample. Is there any way you can balance a single sample? No. You just put in that one single sample, the model will predict for you what is the class is supposed to belong to. So that is why I say that it's not compulsory to have a balanced number of samples coming in for testing or validation. But for the first training, this is compulsory. But without balancing, you will not be able to be sure that your testing is correct. So that's why I recommend that training is compulsory, but balancing is very, very necessary for testing. Very necessary for testing. Because without that, you might not be able to know if it's able to correctly classify all the classes. But once we are trained and test, this should be the minimum. For your training set and testing set, yeah, you cannot fit balance. Because it is a testing set that will be sure that your model is good. But for subsequent validation, or when you deploy it to the company, it's not compulsory for them to provide all the classes. Whatever class they have, they should bring it. The system will tell them what is it going to be. Is it class A, B, or C, or D? I hope my explanation is clear.
Yes, one question relating to just what you explained.
Okay.
Now, what would be the best approach? Balance the whole data set from the beginning before doing the stratification, or stratify into the maybe 70-30 and then balance individually? Which would be the best approach?
Well, the best approach is to balance. When you say you use smooth, actually everybody expects you to have balanced the data. You get the point now. It is after you have trained and test your model, then when you go to production using, you have deployed into a company, then the company doesn't need to have all the classes before they can use it. They can use it one by one. There's one sample today, we classify. Another sample tomorrow, we classify. Because what matters is the model is already built. And you cannot build the model successfully without correct training and also testing and validation, as the case may be. So the best practice is to do smooth on the complete data set. Then you partition it after the smoothing. I hope that is clear.
Yeah, Jazakumullah.
Barakallah.
And the second question, I hope I'm not taking too much time.
Okay, we can rush it over. It's okay. Now.
Okay, sir. Yeah. I have this same 4-class problem. I've been trying to work on it, but the maximum I got about for the accuracy is maybe about 87-88% after doing hyperparameter tuning and all the other stuff.
Okay.
So I don't know if there is any advice or any other thing to at least push it forward to maybe 90 or even higher than that.
Okay, you have tried feature selection?
I've done feature selection, I've done hyperparameter tuning.
Okay.
I've also tried this mode, but I will repeat it again with what you just mentioned. Yeah.
Okay, then did you try to work on normalization, normalize your data? Have to try that?
Yes, normalized.
You normalize the data, eh?
Yes, yes.
Yeah. Did you use the original data without normalization also?
Yes.
So, and Notice still work, eh?
Yeah, it's not going
Okay,
more
so
than-
what I would suggest is a couple of other things to check different algorithms. So, and then have you tried the ensemble method?
I tried voting. It
Yeah.
didn't improve it.
Okay,
I
so
tried voting and stacking.
okay, sometimes we have to work on a couple of other methods. So it depends on the data. Some data set, no matter what you do, it's just that maybe the data is not really very relevant to the target we are trying to predict. But we cannot conclude until we have exhausted all options. Even the Kaggle I just used today as example, sometimes they bring out a competition that people struggle from 20% accuracy. They keep going, then they start deploying ensemble until they push it to 80, 90. Sometimes they are not able to achieve 90, by the way. So it depends on the data set and how really related the features are to it. So I think for the sake of time, you can engage me later, okay? I can be able to look at the data critically, then maybe I might be able to offer some insight, inshallah.
Okay. Yeah.
Barakallah fiik, eh? Now, so okay, Mohammed Balogun, briefly before the time, because of our time. Mohammed Balogun.
Assalamu alaikum, sir.
Wa alaikum salam wa barakatuh.
Jazakumullah khair.
Wa
I just want to quickly ask now. We have for the K nearest neighbor now, we have 100% accuracy.
Yeah.
What does this actually mean in terms of when it's going into production? Because when we have 100% accuracy now, does it mean that our any this thing that is brought for prediction, our model will be able to predict successfully, correctly, or does it actually have other things that we need to do before we can actually say this model works?
Thank you very much for that. Yeah, actually, exactly what you have seen, you see here is the reality. That is, it means now, if you give me data that they fall to the same category of the sample I have here, that is going to be able to predict for us with 100% confidence level. Yeah, that you can be sure that the result is going to be correct. However, I call this is preliminary work. Preliminary in the sense that this is very big data. I would like to break the data to 3. Sometimes 4, but at least 3. So I will have training set, testing set. After that, the one that is hidden again, we bring it back in again as the validation set, the third time. Then after that, we can beat our chest that yes, data that are within this same range, they are going to work. However, we depend on where this data comes from. This is the issue. And that's the challenge with one of the challenges with machine learning. If this data is from a particular community, maybe from one country, then if you run tests on those people from that community who share the same attributes, it might work for them. Yeah, 100%. Everybody that come to test him or myself will get correct prediction. But when we bring it to another country or another community, if they happen to share the same attributes based on information, the range of data, for example, you have another community that the cholesterol level in their body, even though it is high, because if you go to detail of that data, you notice that people with higher cholesterol level, they might fall to a particular category in the prediction. But we have another country that even with very high cholesterol, they are doing fine. They didn't have any hypertension problem. In that case, that will break the model you have built because it was built on data set from a particular community. So you cannot generalize to another community except they happen to share the same attributes. So in this case, we can say that if you bring new data that conform to the same data distribution we've had, definitely they should be 100% certainty that they're going to get correct prediction. And that is why we need to look at the distribution of the data. What is the mean? What is the standard deviation? And what is the minimum? What is the maximum? In most cases, if people fall within all those statistical analysis attribute of the data, their prediction should follow the same pattern. Wala wala. All things being equal. I hope I clarified
Jazakumullah khair. Thank you
where
very
you
much.
come. Barakallahu feek. Yeah. So, but the fact that it's work for this actually is a very good step, because now, if we want to get data sets for this kind of hypertensive work, we can now request for these same attributes from another country, because it seems those attributes are working together. Because we have data in the past, we struggled to get 60%, by the way. But this data set seems the attributes are very unique. So we can target this attribute and then get data from the local community and try to build a model for that community. This is one of the challenges. We call it heterogeneous prediction. Is very challenging. I mean, when you want data from different places to predict for data from another place, it's one of the very challenging areas people are trying to explore in machine learning. So thank you very much for the time. I believe that is what we have for the day. So we appreciate all those people working behind the scene that made this presentation possible. So we appreciate your time and all the supporters, people that have been working behind the scene. Thank you all. We appreciate you. And till next week, inshallah, we're going to meet. Have a blessed day ahead of you, and wish you all the best. Assalamu alaikum wa rahmatullahi wa barakatuh.